Hello everyone, welcome to Code and Learn. So in the last video, we set up our makefile for enhancing the local dev experience and setting up lint formatting and detecting any breaking changes with the protobuf files. In this video, we are going to implement some of the RPC calls. So if we go back to our product, you will see in our service, we are defining two RPC calls. One is create and the other one is get. Create is to create a news and get is to get a news by its ID. These are the simplest form of RPC calls. This is also known as Unary RPC, which is the most basic type of remote procedure call interaction supported by the gRPC framework. It is very similar to the traditional request and response model of HTTP. The client sends a request, in our case create request or get request, and then the server processes a request, returning a create response or the get response. Now if we go back to our server, you will see we embedded the unimplemented new service server so that the interface of our service is satisfied. And if we go into the unimplemented new service server, you will see there are these methods defined on the server, and for both we are returning unimplemented. Now if we define the same methods on the server, it will override the implementation of unimplemented new service server. So let's do that. Func server, then create. Let's just copy these two methods and do something like this. Instead of this, I can say s server. Similar here, which is s pointed to a server. So these methods are defined on the server. For these, we need to do news v1 dot. So I can do a similar thing for other request and response, and that's it. So we are doing the same thing as a unimplemented new service server. Now to have our custom implementation, I'm just going to use a memory store that will store all the data for news in the memory of the program. I'm not going to use Postgres in this project because we only want to concentrate on the gRPC framework. So first, let us create the mem store. So inside internal, I'm going to create mem store. Here I will say store.go, package will be memstore. The first thing I'm going to define is the news object that we are going to store in the memory of the program. So I am going to say type news struct. So if we look here, the news object has ID, author, title, summary, content, tags, created at, updated at. So similar to that, we are going to create these fields. ID, which is of type UUID, then author, which is of type string, title, again string, summary, again a string, content string, then source is of type url.url. I don't want to use the UUID from Docker, so I'm just going to remove it and import the correct one, which is the one from Google, and that's it. For created at, updated at, and deleted at, I'm just going to use time.time. So that's the basic implementation or the model of news that we are going to store in the memory. Now let me define the store struct. Type store struct. First thing I'm going to add is a lock, which is of type sync.readWrite mutex. Then I'm just going to create a slice of news pointer. This is the slice we are going to use to store the news objects. Then I'm just going to create a constructor function new, which will return a pointer to the store. Inside it, return a pointer. For lock, I'm just going to use sync readWrite mutex. And for news, we will create a new slice with make. When we initialize it, we have a capacity of 0. So the two methods that I want to add on this memstore are create and get. So let's do that. Create, which will accept the news object and return the created news. So accepting a pointer and returning a pointer. Here I will say created news is equal to news. The ID is going to be generated by the store itself. So I'm just going to use uuid.new. The author we are going to fetch it from the past new. Similar for the all other news parameters like title, summary, content, source, and tags. Tags is something we missed here, so I'm just going to do tags, which is again a slice of string. And now I also want to update the timestamps. For created at, I'm going to use time.now.utc, similar for updated at time.now.utc. Now let's acquire the lock so that we can write to the slice. I'm using a lock because multiple Go routines can access the store at the same time. So we are just going to use a regular lock because we are going to write to it. And then therefore unlocking it s.news, that is append the news or the created news to the existing array, and then just return the created news. That's it for the create method. Now let's create a method to fetch a news by its ID. So func store get takes ID, which is of type uuid.uuid, returns the news. Inside it, we will just range through the slice to find the news by its ID, but first we need to acquire the read lock. So we will do s.lock.rlock and then defer unlock it. So s.log.r unlock. And then let's range through the slice and try to find the news with the same ID as the passed in ID. So I will say if news.id is equal to the passed in ID, and if the deleted add timestamp is 0, that is it's not been deleted, then we return the news with the matching ID. If we don't find anything at the end, we will just return nil. So that's it for the two methods that we require to implement our server methods or the gRPC Unary calls. Now let's go back to the server. Here we are not going to use the context, but we are going to use the request. I'm just going to rename it to in. If you look at create request, everything is a string. So we need to turn some of these fields into the types that we have defined in the store, like ID, which is of type UUID, and URL, which is of type URL.URL. To do that, I'm just going to create a function here, which is parse and validate. It will accept a function parameter of type newsv1.createRequest and return a news of type memstore.news. Errors, if there are any, when we validate the input. Later on in this project, we are going to use a library to validate these fields. But for now, we are doing it manually. Here I am going to use errors because we want to append multiple errors if validation fails for multiple fields. Because I feel like it's a good user experience if you send all the validation errors in the response instead of user having to make the call again and again if one of the fields keep failing the validation. So if ID fails the validations, they will rectify the ID and send a request, but this time the author fails the validation. So instead of having to make multiple calls, we can just send in all the validation errors. First thing I do is to check if in or the passed in request is nil. Then we return nil for news and a new error, which is error.new news request empty. Next thing we check is author. If author is an empty string, this time we are going to append the errors. Since errors has been initialized here, we can just use it and set the errors is equal to errors.join any previous errors, and then errors.new author cannot be empty. I'm going to do a similar thing for title, summary, and content. So checking if they are not empty, and if they are empty, we are going to append the errors. Next, I'm going to validate if tags are not nil. So I can say if tags are nil, I want to append the error tags cannot be nil. Then I also want to check the length of the tags. If they are empty, we want to return an error. Now let's move on to the ID. We want to parse it into a UUID. So we do a similar thing, which is parse the ID using UUID.parse. If it fails, we add the error to our errors. Similar thing we will do for source URL. We will use URL.parse to parse the URL, and if it fails, we add to the error. Now, since we have validated all the fields, we want to check for errors. So if errors is not equal to nil, I want to return early and say nil for news and errors. If there are no errors, what we want to do is return the parsed news in the form of memstore.news. So that's the basic implementation for parse and validate. So back to our create, we are going to parse the news first, which is parsed news or error, parse and validate. Pass in the incoming request. If errors are not equal to nil, this means the request doesn't match our validation. So we can say return nil for the response and errors. For error, we are going to use the status package. That is the gRPC status package. We are going to do status.error for code. We will use codes.invalid argument. And then for string or the message, we are just going to use the message from errors received. So what we are doing here is very similar to what we do with HTTP. With HTTP, you will return a status code of 400. Similar to that, gRPC has codes. In our case, which is invalid argument. This package allows us to send the codes along with the error message. That is status.error. Error returns the error representing CN message. So basically, it's turning the error response into a gRPC compliant error. So on the client side, you can check the error codes to figure out what is the problem. As you can see from the imports, both are part of the gRPC framework. There are other error codes that you can have a look. I will add the documentation for that in the video description. If everything works fine, we say created news. Now store.create. So as you can see here, I'm trying to access a store on the server itself, but we have a defined int. So let's go back to it. Here, I'm just going to define an interface to say news storer interface, which has two methods, one for create and the other one for get. And then we will say here store, which is of type news storer. Here we need to accept that store, so news storer. Here we set the store to the past in store. That's how we will access the store. Now after creating the news, we need to transform it again to the create response, which is what we have in the generated code. To do that, I'm just going to create another function, which is a simple function to convert the memstore news into a response. So func to news response news memstore.news, that is, it will accept memstore news and return news v1 dot create response. Inside it, we will do return pointer to news v1 create response. For id, it is a type of string, so we can say news.id.string. Similar for other fields. For source, we are just going to use the string method defined on the URL object. Save it. Now for timestamp, we are going to use this package, that is timestamp pb, which is again a Google provide type for protobuf timestamps. So I can say created at is equal to timestamp pb dot new and use the timestamp from the news or the memstore news. Then I'm going to do a similar thing, which is updated at timestamp pb dot new news dot updated dot utc, and that's it. So we are going to use that function in here. So I can say return to news response, pass in the created news and nil for the error, and that's it. So that's the implementation for our create RPC or create Unary RPC method. Now let's look at the get method. Again, we are not going to use the contact, so we can just use underscore. I'm going to name it in. First thing we need to do is parse the provided init into a UUID. UUID.parse in.id. If there are errors parsing the UUID, we will do a similar thing, that is return nil status.error codes.invalid argument, and then just use the string from the error. Otherwise, we are going to use the store to fetch the news. So we will say fetched news is equal to s.store.get. Pass in the UUID we just parsed. Now, if fetched in news is equal to nil, we want to return early because there are no news found for the given ID. We will say nil status.error, use the codes again. This time we are going to use a code of not found. That is, the object we are looking for is not found. So we will say news with given ID not found for the message. Otherwise, return news v1 get response and nil. You can create a similar function as this, but for this one I'm just going to do it in the method itself to have something different. But ideally I will just create a function to do that. So I don't need to do much. I can just copy this from here, paste it here. In here, we are just going to use, instead of news, we need to have fetched news. And that's it. So that's our implementation for both the create and the get method. That should satisfy our service or the RPC service that we have defined here. Please note these are the Unary gRPC or RPC calls. As we go along the project, we will also work at methods that implement server-side streaming, client-side streaming, and bidirectional streaming. Now the last thing we need to do is initialize the store and pass it. So we can just say memstore.new. So that's it for this lesson. In the next video, we are going to use the gRPC client to call these methods on our gRPC server so that we can understand the end-to-end flow. That's it for this lesson. I hope you enjoyed it. If you have any questions, please post a comment under the video or reach out to our Discord server. Until next time, happy coding.